Hello students, in today's class we are going to understand stoichiometry and mole concept. So what is the meaning of stoichiometry? So you might be seeing lot of chemical reactions and somewhere it is said कि अगर 1 mole हमने reactant दिया है तो how many moles of products are going to form, how much product is going to be let's say formed in this reaction. So that is we are going to understand this part. So let's say if a balanced chemical reaction is given. So for that you must know balancing of chemical reaction, which I have explained in another class. So balancing of chemical reaction, that is must for this concept. So let's say if a balanced chemical reaction is given, let's say example, we have given NaOH plus H2SO4 gives Na2SO4 plus H2O. So now we have to balance it. So we have 2 sodium over here, we have to write 2 times over here 2 NaOH. Now we are going to write H2SO4, so Na2SO4 plus 2 H2O. So this is going to be a balanced chemical reaction. Now you can see in this reaction 2 molecule of NaOH reacts with 1 molecule of H2SO4 to form 1 molecule of Na2SO4 salt and 2 molecules of H2O. Now this relation which I have written over here 1 and 2, that is called stoichiometric coefficient. That means whenever NaOH is going to react with H2SO4, its 2 molecule is going to react with 1 molecule of H2SO4. So 2 will react with 1, 4 will react with 2, 10 will react with 20, 100 will react with 200, 6 into 10 to the power 23 will react with, okay, I have written opposite over here, 20 will react with 10 and 200 react with 100. So 6 into 10 to the power 23 will react with 3 into 10 to the power 23. Okay, so this is the relation. 2 will react with 1. So 4 will react with 2. 20 will react with 10. Half हो रहा है ना? 200, 100. 6 into 10 to the power 23 will react with 3 into 10 to the power 23. 6 into 10 to the power 23 is called 1 mole. So 1 mole will react with half mole. 2 mole reacts with 1 mole, again the same relation. Okay, so the importance of a stoichiometric coefficient and the balance reaction is to identify how many molecules are going to combine with let's say molecules of another substance. I'll write one more example. So let's say the reaction is given as N2 plus H2 gives NH3. So now we need to balance this reaction. We have 2 nitrogen over here, so that's why we have to write 2 over here. The nitrogen is balanced. Now we are having 6 hydrogen, so 3 H2. So 1 molecule of N2 is going to react with 3 molecules of H2 to form 2 molecules of NH3, ammonia. This is nitrogen, hydrogen, and it's going to form ammonia. And this reaction is called Haber's process, industrial process to manufacture ammonia with the help of N2 and H2. Anyway, so now you can see over here we are having stoichiometric coefficient, I am writing in short SC. We are having, if something is not written over here, that means it is 1. 1 into something is same. So 1. The stoichiometric coefficient of hydrogen is 3. And the stoichiometric coefficient of nitrogen is 2. Ammonia is 2. So we are having stoichiometric coefficient 1, 3 and 2. Now that means, let's say, imagine if there is a one molecule of N2, where one nitrogen is represented by like this, and we are having, let's say over here, 3 molecules of H2. 3 molecules of H2 I am writing like this, okay, over here. Three molecules of H2. Now every chemical reaction is just a rearrangement of atoms. A chemical reaction, you might remember, in a chemical reaction the mass remains conserved. So the chemical reaction is nothing but rearrangement of atoms, right? So over here we are having 2 nitrogens, here we are having 3 molecules of hydrogen, right? So 6 hydrogen atoms. Now we are just rearranging them. Now this nitrogen goes with these 3 hydrogen, is going to form ammonia. 2 molecules of ammonia. So now you can see 1 molecule of nitrogen reacts with 3 molecules of hydrogen to form 2 molecules of ammonia. And this relation is going to valid for, let's say, any number of molecules. If we are going to write 10, so it is going to be 30, it is going to be 20. If we are going to write 6 into 10 to the power 23, the stoichiometric coefficient was 1, 3 and 2. So we are having 6 into 10 to the power 23, then we are going to have 3 into 6 into 10 to the power 23, then it is going to form 2 into 6 into 10 to the power 23. That means it is 1 mole, it is going to be 3 moles, it is going to form 2 moles. So 1 mole will react with 3 moles to form 2 moles. So anywhere, if any information is written about moles, we can directly calculate how many moles of ammonia will form. So let's say one example. If somebody said, if 2 moles of nitrogen is present, nitrogen reacts completely with 6 moles of hydrogen. How many moles of ammonia will be formed? So it is simple. One is going to form 2 moles, then 2 will form 4. Okay, that is called unitary method. So we are going to say 1 will form 2, then 2 will form 2 into 2, that is 4. So we are going to get 4. Okay, unitary method, simple calculation. 1 will form 2, then 2 will form 4. So this is going to called as mole concept. You can apply unitary method simply and then you can write. So let's say I will give you one more example. Let's say somewhere it is written as, let's say, I will write in ABCD. So if I am going to write, let's say A plus 3B is going to form 2C, let's say. Okay, that is simply like N2 plus 3H2 gives 2NH3. Let's say ABC. A, B and C are going to be 3 substances. Then stoichiometric coefficient you can write 1, 3 and 2. So if somebody said, let's say how many moles of B are required to react completely with 5 moles of A. You know? How many moles of B are required to react completely with A. Okay. So now you know the relation is 1:3. 3 is going to react with 1. So now they are saying 5, then how many? So you can simply say 5, then 5 into 3, that is going to be 15. So these are the very simple problem, so that we can calculate how many moles of reactants are required to react completely, how many moles of products are going to be formed. Okay.